Hello, good morning or good afternoon. Thank you very much for attending this workshop devoted to artificial intelligence and big data, what we consider the InsurTech drivers. Today, we are going to present the results in 4 of the pilots of the Infinitech project. For those of you that you don't know about Infinitech, Infinitech is an European research project under the program Horizon 2020. Infinitech is considered a flagship project in the Fintech and Insurtech domain. Relevant technological companies and research centers are participating in the project, providing cutting-edge technologies. These technologies are applied and tested in 17 pilots in both domains, fintech and insurance. Today, we will provide you 4 presentations about our advance in the 4 insurance pilots belonging to the insurance clusters. But let me introduce my colleagues. We will have Ignacio Elizegui from ATOS, who will present the pilot devoted to automotive insurance domains. After this, we will have the presentation about the health insurance products by our colleagues from Innovation Sprint, Aristodemos Nematikakis. After this, we will have the presentation about the artificial intelligence insurance risk selection and insurance products for our colleague Carlos Albo from the company Wenalyze. And to finalize with the Grigoris Mygdakos presentation about agro insurance products from Agro Apps. Then let's start with the first pilot presentation about artificial intelligence applied to driver profiling and enhanced risk estimation, one of the pilots of the Infinitech, presented by Ignacio Elizegui from ATOS. Ignacio, the floor is yours.
Okay, thank you, Carmen. Thanks for your presentation. Well, I don't know how many attendees we have behind the screen because I don't have the information, but I suppose we will have plenty of them. So let's start with the first one, with the first session. As Carmen introduced, this one is oriented to AI applicabilities into the car insurance area by analyzing the driver's profiles. This is the driver's behavior and so provide this way new and enhanced ways to estimate the risk linked to the drivers. Okay, this one, let me go to the screen. Yes, this presentation belongs to the pilot 11 of Infinitech that exploits mainly connected cars as an IoT infrastructure. For those who attended to the previous workshop, in that we already present all the business innovations and all the main objectives of the pilot, right? So right now my idea is to present the real assets we have already developed on the environment of this pilot, to present what we are doing and what will be our next steps on developing real services for a real usage, right? So as a summary of our previous workshop, for those who can attend, it can be useful to understand the objectives of the pilot. I will use the business innovation we are working on. The first one has to do with the accurate risk assessment. The traditional way, we try to let's say evolve to provide a new way to estimate risk and a new way to provide customized services to the end user. So in this sense, the traditional way of pricing for focusing on the car insurance area was based on statistical data, mainly based on the age and experience of the client, of the insured client, the characteristics of the vehicle that is being where this car is supposed to be driven, right? Now, with the introduction of real-world data, which is we are capturing within our framework, and also applying AI technologies, we propose new ways of pricing, new ways of provide customized services, new ways to calculate or recalculate the primes of the insurance the insurance clients, but fostering the usage-based insurance concept that probably those that works with insurance probably know better than me. Right? In this sense, we will be able to capture real data from the vehicles. So this way we can know how the vehicle is used by the driver, how many kilometers it drives, how in which areas the drivers drive the vehicle. Also, we can know different parameters of the driving behavior about how the driver drives its car, how many times it brakes, how it accelerates, how it turns the steering wheel, how it manage the vehicle. And also we can collect information, what we call context information. This is information related not directly to the car, but the area or the context the car is driven. This is, we can have information for weather, we can have information from traffic incidents, traffic jams, and these kind of things. Also, as another service, by exploiting the real data we are capturing from these vehicles and from the context area, we also plan to provide new ways to help and assist. I'm seeing the slides moving. Oh, sorry, I am not sharing my screen. Sorry, I thought I was doing that. Okay, I think this is better now, right? Because it will serve me to show you the real tools we are working. So as I was commented, we plan also using this information, this real world information, to evolve the ways the fraud detection or the fraud is detected or managed by the insurance companies. From the traditional way of detect frauds, so we know more or less are based on reports from police or let's say subsequent analysis by experts in order to know what was the real conditions of a given incident, right? When we use this kind of approach, we can connect the vehicle to the cloud. We already know what was the conditions, the real conditions of a traffic incident. We can know what was the real weather, what was the real area where the driving was, where the car was driven, and we will know what will be the real car driven. And also, by applying the driving profile model, we can infer who was the real driver involved in an incident. So this way, we also plan to provide a service that improves the fraud assessment for the insurance companies. So, having introduced the main targets of the final services we plan to develop within the pilot, my idea now is to show you the assets we have already developed. In order to support what I have already mentioned, the Pilot 11 planned an architecture, right, to integrate all the information and to focus the data flow in order to support the final services. In this sense, for this pilot, and I would say this is the main asset we have real data, right? We have real connected cars, we have real information for weather, and we have real information for traffic incidents, for traffic alerts. Okay, here you can find the real data sources we are integrating in our framework. Well, we within Pilot 11 we have developed specific connectors based on standards, right, in order to capture all this information, integrate, homogenize, and later serve this information in a homogenized way to the rest of the components of the framework. So this is done by the Smart Fleet framework. Okay, here you can find all the information gathered from these devices through standard connectors into an homogeneous way. Later, this information will be supplied to the AI platform that here it will be analyzed, stored, classified, and organized in order to feed the corresponding models to design and to develop the corresponding AI models to create the driving profiles and later classify the driver's behavior. And these models will be the base, will be the key component to finally develop the fraud detection, the pay-as-you-drive services, which are the final targets of the pilot. The idea of these services will be fed with real insured clients' data, and then so the insurance company will have the classification of their drivers, and will also have information required from the insured cars to analyze possible fraud case. Also using the information that we gather within the Smart Fleet platform, we also work on a simulation environment focused on the area where the drivers, where the real drivers are driving. This will be useful for a later stage in order to train and to test the models we are creating within the framework. Okay, so the Smart Fleet, the component that gathers information, is one of the components we have already developed and have already deployed. This is an open platform. It is based on standards and open components. Here you have a list of the standards we use in order to implement this, to implement the components that stores and homogenize the information, and the components to gather the information according to specific models given in this environment. Okay, with these connectors, we capture information from the CAN bus of the car and using an ODB2 protocol. This is automotive standards, right? Present in, I would say, 99% of the current vehicles, these two standards, that more or less captures all the information of the tons and tons of sensors that each of the car has already deployed on it, right? For current cars, we have a specific component provided by CTAC that it's called the Hybrid Modular Communication Unit that is connected to this interface, the ODB2 interface, and is able this way to capture all the information produced by the car and upload this information into the cloud, into the Smart Fleet. Okay, this is for current vehicles, from vehicles provided within this century, okay? But for new vehicles, just having in mind the new vehicle-to-vehicle and vehicle-to-infrastructure paradigms that will support later the concept of the smart driving and autonomous cars, I would say that new vehicles will already build on top devices able to share information with the cloud. Okay, apart of this, there are other available devices that can connect to the ODB to interface and gather information. There are applications for mobile phones, there are applications for many other devices that can capture this information and potentially share this with a given cloud. Right now, with this infrastructure, we have captured about more than 18 millions of vehicles records corresponding to the 20 real vehicles that are currently driving since April 2021, which correspond about 4 gigabytes of data only related to real vehicles. Let me show you right now. This is just a capture of the current, but I guess that you can see right now the real platform. This is just a set of dashboards we have created on top of the databases that the Smart Fleet has. The real power of this framework, it's on the data it's stored on the databases, on its databases, and the interfaces it provides in order to share and serve this information. This is just a set of visual dashboard we have created on top of this platform using these APIs, and this we can see. For example, we can see the real data we are capturing. Let me see. This is just a dashboard. As you can see, this is information coming right now. It takes it time to load, but you can see here the last measurements we have from the 20 vehicles. This is we can see here, for example, we have here a current vehicle that is driving, which is 10227. Because currently driving, we can go to the specific and check the vehicle that we have been monitoring. I think this was this one. Yes. And you can see here the real data of the current data of that vehicle. That vehicle is currently reporting to the framework. If you wait a bit, you can see this snake moving, representing the data, the real data of the vehicle. I don't know which position, but you can see the current speed, the instant acceleration of the vehicle, and where it is driven. Also, we have more information about about the current. This is the historical speed, the acceleration. It is not reporting fuel consumption, but we have more information here. This is the real relevance of the infrastructure. Okay, in this sense, we also have information about traffic alerts, all belonging to the area with CTAG belongs, this area of this of the north of Spain, right? We have the list of the different traffic alerts we have capturing, and also we have information in the platform about weather. This is the last report, the last 7 days reports of weather from the 3 weather stations we have deployed in this area. Okay, this is just an example of what's the information behind the platform. Okay, I can skip this one and this one. Yes, so using or exploiting this information, we are currently working on the driving profiling, artificial intelligence powered model. Okay, the building block that provides these models are kind of black box, right? That implements different technologies in order to analyze and propose different clusters of data, right? This is the different information from the vehicles are classified in clusters, what we call clusters, in set of routes. The information coming from the vehicles are grouped within our AI framework within routes. Understanding a route as all the technical information from the vehicle, acceleration, speed, location, steering wheel, angles, from a period within a given period of time. Ideally, a route will be started when you start the engine of your vehicle and will be stopped when you stop the engine of your vehicle. But in practice, we use time slopes of 1 hour, of 2 hours, 15 minutes in order to identify sets of routes. And these routes are later classified by the AI model into specific clusters, right? So if you drive in a specific way, perhaps your route will be classified in this cluster. This is what we have right now. We only classify clusters. We can only identify clusters. Later, using target data, we can put a name on the corresponding cluster, but telling, for example, cluster 2 corresponds to the aggressive drivers. Cluster 1 corresponds to passive drivers. Cluster 3 corresponds to, I don't know, normal drivers, using the target data and the, of course, useful help of our insurance company. So in this sense, this is how the driving profile AI model works, right? We are using all the information I have mentioned before in order to provide to feed the data engineering model of the driving profiling service, right? So this way, all this data we are managed, we let's say analyze all this information. We try to create sets of information. We have, for example, can create traffic density maps in order to identify which areas are more have more traffic. We can identify also areas. We can define areas. For example, this can be an urban area. This can be a surrounding area. This can be a highway area. That will be also useful for us in order to refeed the platform with new information that will help to classify later the drivers. Okay, so this module just homogenize and prepare all the data in terms of connected cars, weather, traffic alerts, and also roads to be later analyzed by the AI model, right? This information organized in here will be used to create the AI model, to train the AI model, also to test the AI model. So at the end, we have a service that implements this AI model that given a driver's route as an input will tell you in which cluster that route is classified by the AI model. Okay, and also we providing explainable AI libraries that helps the end user to understand why my route has been classified in cluster 2. This is a bit shown in the previous slide, where we can present different graphic information about what is the relevance of each of the parameters on each of the profiles, right? So in this sense, we have also deployed the service. Let me also show you how this works, because we have also deployed this service. You can see it here. This is just a front end in order to illustrate how this service works. Indeed, it is just a REST service that consumes a route given by the end user and then just returns a specific cluster classification, a number of the cluster where this route belongs, and also a set of metrics related to that route. In that sense, we have already tested some. For example, I have here a file. This is just a file with containing a route. This is a set of technical vehicle linked to a specific route. This is a set of location parameters, speed parameters, and this kind of things that defines a route. And then once you run the service, it will give you the result. So this route was classified in profile 1, and it's the route lasts 172 seconds. The mean acceleration was this. This is it consumes 16 liters every 100 kilometers, and this is the mean speed and the route length. Okay, so it gives you the the cluster and also some metrics that may help you to understand the classification. So this would be the two components we have already deployed and we have already using in order to implement our last services. These are the pay as or pay as how you drive, the user-based insurance services we plan to use. This is we will know the behavior of the driver, and in terms of the way he drives on or how the driver drives, we can provide different prices, different premiums, or different let's say products that may serve the well. And also in the other for the other service, in case that something happens, we can have all the information from the platform related to that moment. We can have the route, the previous route followed by the car. We can analyze the the driver profile. We will know the weather conditions in order to provide detailed information to the insurance company so it can have a better analysis of a possible fraud case. So this would be the main things I wanted to present you. This is how we put in place what we mentioned, or we told you during the first workshop. I don't know if you have any questions. If not, Lucille, you can perhaps trigger the questionnaire.
Yes. Yes. It is on the chat. So please, may we ask you to complete the following questionnaire on the G form for pilot 11. And I think we can go for the next presentation. Carmen.
Perfect. Yes, we should go for the next presentation. We have our colleagues here, Aristodemos Mygdakos. So please, the floor is yours. Thank you very much.
Thank you, Carmen. Thank you, everyone. Good afternoon. I'm going to present you similar activities, only now from the healthcare, from the health insurance perspective. So let me start sharing my screen. Okay. So this is pilot 12 of Infinitech project. It's on personalized health insurance products. The problem at hand is similar to the car insurance. We need to have accurate risk assessment in order to hope to actually personalize the insurance premiums. Today, the situation is a bit static. We collect information about the insured person, their age, gender, marital status, occupation, habits, smoking, alcohol, etc. We get information from their health record, and we also use the type of insurance plan they have in mind in order to determine the pricing. Once determined, premiums remain unaffected, unless, of course, there is a claim, meaning after a disease, after an accident. There is a solution, though. We can actually offer personalized and dynamic products if we utilize real-world data and we integrate this data into risk assessment. Real-world data can be collected with activity trackers, either simple bands or smartwatches or anything in between. And we also use health applications in order to collect more information about the people that are using these systems. What if we could actually use all this data collected in the insurance business? Well, we can. In Infinitech, we are promoting the use of Healthencia, a platform that on the one hand side gives the insurance company clients an application. Using this mobile application, people can actually seamlessly answer questions or connect their activity trackers or any other measurement system they have into the system and get data about them, whether they are using Android or iOS devices. Healthencia supports all Fitbit and Garmin activity trackers, but also supports Android-specific and iOS-specific measurement systems. In this application, users also report data and events about their life using the in-application questionnaires. On the other hand side, the other type of user, the insurance professional, is also having an application on their fingertips. That's a portal application where they can see data about people. And the data looks like this. So here you can see actually my data. So there is no GDPR issues here. And in terms of physical activity in the last quarter, and you can see, for example, that my physical activity suddenly dropped spectacularly for some days. You can also see that my resting heart rate increased, and my sleep habits changed with spending quite some awake time while in bed. So obviously something was wrong. And if we also go to see the overview and the reported events, you can see that in the same period there was an excess of reported events. It was actually a time of sickness, as the data actually say about me. So returning to the presentation, we can use all these data for personalized health assessments. We use machine learning models for the analysis of the insured person's behavior throughout the insurance period. And this results to a personal score. You can see examples of this personal score across time in graphs about two different people. Insurance companies can provide personalized insurance products based on this score. The real-world data determine the score, and the score itself is reflected in health insurance premiums in frequent intervals. How is this done in action? Well, we collect data using Healthenzia, and at regular intervals, we retrain our health outlook model. This training happens in a special testbed outside of the Healthenzia system, where the data are obtained using a system from Uptake, one of the partners in the pilot. The data is monitored for regulatory compliances using the data protection orchestrator built by ATOS, and it is anonymized with an anonymizer built by Gradient. The anonymized data are stored in Linux scale database, and then our own model training actually happens. And this model training provides the models to be used in two services, the risk assessment and the lifestyle coach. We train these models, and then we infer on clients daily, accumulating decisions into a well-being assessment. This assessment is shown on the right-hand side. Starting with the initial interview, the insurance professionals know about 4 categories of clients they have at hand, and they can actually personalize the insurance product to these people. They have the feeble, the unfit, the normal, and the quite athletic people at hand. By monitoring this score for these people, they actually get histograms of scores like those you can see here. And immediately, we can observe 2 things. First of all, the normal and the athletic people overlap quite a bit. This is to be expected because it's quite difficult to tell the difference at the limit where normal stops and being quite athletic actually begins. And also, normal behavior is sometimes quite good for your health. So the health assessment is actually high for them. On the other hand side, you see that the unfit people have quite lower scores. Some of them do have scores compatible to the normal people, and maybe these are eligible to leave the unfit group, this tail here, and start being considered from the insurance viewpoint as normal people. And you also see the feeble people that are at the bottom of the scoring, with a bright exception here. So perhaps this person needs to stop being considered a feeble one and start paying less for their insurance. So this is what the insurance professionals have at hand. They can also see clustering results about their patients. You can see examples here from clustering all the data we collect using different methods. And you can see how these clusters are actually modeled into groups of people and how the well-being assessment changes for people in the different groups. Professionals can immediately associate names to these groups that are automatically obtained from the components in much the same way that you saw in Pilot 12. There is a challenge to deal with, though, and this is fraud. So far, it is well known that people who use activity trackers and mobile health applications are quite resourceful in tricking them without having any benefit apart from the satisfaction of getting the next badge out there. Imagine what can happen if people can have actual benefits from misusing the application, from tricking the activity tracker into thinking there is much more activity than there actually is, or answering to the questionnaires in an untruthful way. We utilize two approaches to address this. First of all, we train our systems with data that come from secure sources, so from people that have no benefit from actually answering wrongfully, and then we perform outlier detection, and we do not actually consider the data that are outliers. But this can get you only this far, signal processing. What is better is to provide people with the incentives to actually use the system correctly. And the incentive we have thought of is to actually give them a service of coaching throughout their life in the insurance program. So we actually get information from all the decisions we have from the person, and we try to use this information in order to persuade clients they have to gain from being truthful. This virtual coaching actually utilizes explainable AI techniques. We analyze every decision, and no matter if the decision is positive or negative, there are factors influencing the decision towards a positive outcome and other factors influencing the decision towards a negative one. We identify the most influential factors for the specific decision, and we coach our users towards the positive factors and away from the negative ones. This is advice that is calculated per person and for the given time. So it's actually very, very much personalized. Regarding the business innovation behind our proposal, we are actually introducing the usage-based insurance in the health sector. We are personalizing the offers for health insurance by capturing and processing real-world data from insured people. We are adapting the health insurance premiums to the insured person's lifestyle by providing real-world data of their lifestyle. We also need to detect fraudulent behavior, and this is done by detecting the abnormal behaviors and by motivating the insured persons. We put our trust more into the second domain. Thank you for your attention, and now it is time to answer the questionnaire for Pilot 12, if you please.
Oh, okay. Okay. Thank you very much, Aristodemos. Also, I think we are going to stop a little, try to have a break to answer the questionnaire. So please, Lucille, can you provide the questionnaires?
Yes.
And let's see.
You will find the questionnaire on the chat box.
Okay. So please.
This is very useful for us. So please don't hesitate to answer the question for pilot 11 with the first link and for pilot 12 with the second link.
Well, we will wait like a couple of minutes in order to see if we'll have the question from the participants. So please fill in the questionnaire.
If you are having troubles in answering the questions, please tell us.
Any sense, Lucy? I hope now maybe people don't have enough time to follow our presentations and to answer the questionnaire. I hope by now we are obtaining this appreciated feedback from them, because we need to know about your opinions in order to continue with the project development. Your opinion is very, very important for us. Okay, Lucille, can you inform us about the questionnaires?
Well, at the moment, I can't see any answers.
Maybe. Is there
1
any
minute.
problem? Yes. Is there any problem? Maybe you can tell us regarding the questionnaires using the chat. Do you have any problems to fill in?
Okay.
We have a question in the meantime. Maybe Aristodemus can answer this. Gabriel Rack say that I am the beginner in big data. I want to know about the technologies used for developing this pilot. Maria is saying that, hi, I can not insert anything in the survey, but maybe that is because I am in the project. No, okay. No, this is not a problem, Maria. I think, yes, maybe it's a problem with the questionnaire.
So regarding the question about the technologies used, I guess it's for the pilot that has just been presented. So for the health insurance pilot, we are actually utilizing IoT devices to capture activity data from people. In some cases, the IoT devices are activity trackers. In other cases, the devices is the smartphone itself, if the person doesn't have an activity tracker, because they are smartphones have sensors today, and together with a lovely invention of mankind called the pocket, it is your phone is turned into a wearable. And then we need to collect all this information. So we do need a platform that is able to collect the information, and that's Healthensia. And on top of everything we measure, we also can simply ask our users about things, because we can always increase what we are measuring, add more devices on the person's body. But sometimes it's simpler to actually ask someone, how is your mood today, instead of trying to use the smartphone's camera and perform an analysis of the mood from the face of the person. And we do exactly this thing. Then we need to process all this data and train models that can actually tell us something about the well-being outlook of the people. How is it looking for them in the short-term future? And that's exactly what we built using our machine learning techniques. And then we apply the model in the way you saw in the presentation to derive a personalized score. And once we have this score and it's changed across time, we can do lovely things like a grouping of people, like viewing how the people are doing in terms of their original classification and if they deviate from that, and actually tune their premiums to their current behavior. I hope this has answered your questions.
Many thanks, Aristodemos, for your question. Maybe I think you have provided a complete question. Well, if you want, we can go for the following presentation. Is Carlos Albo going on Wenalyze?
We just have a few more questions from Ayet.
I can answer in the chat, and we can go on with the presentation.
Great.
Perfect.
Thank you.
Thank you.
Thank you. Yeah, thank you, Carmen. Thank you all. Thank you for coming. I'm going to share my screen so I can show you the presentation. Could you confirm that you are you watching the presentation?
Yes.
Okay, thank you. This is pilot 13, is inside cluster number 5, one of the 2 clusters that we are participating in this workshop. And this pilot is regarding artificial intelligence, insurance reselection, and insurance product recommendation for small and medium enterprises. So one of the major problems that the insurance industry has is that 60% of the critical data regarding commercial insurance is inaccurate, or simply it doesn't exist, or is absolutely not updated. That means that annually in Europe, just in commercial insurance, the insurance companies are losing 7.2 billion of euros because they don't have this information updated. So in this pilot, with Wenalyze and the technologies used from working practice 5, currently working with linear scale, we collect information from open data and validates and updates and enrich data in real time, and we give all of this actionable information to insurance companies so we can improve their processes, so they can know in advance and predict what are the risks in their current portfolios, and also rate better the new clients that they are selling policies. So basically, in pilot 13 and developing this solution, we are doing 2 things, 2 very important things for insurance company. First, we are gaining efficiency, and secondly, we can optimize cost. Regarding gaining efficiently is because some of the use cases that we can serve with this platform that we have developed in this pilot, we can automate the submissions of the questionnaires, so we can improve not only the customer experience, also we gain speed in this kind of processes, and also we can check in real time things regarding compliance about the data that come from the customer or clients and new clients. So they don't need double checking because we can do it immediately. Secondly, underwriting data optimization. That means that we are, let's say, taking out these manual processes to getting data and to analyze this data from the actuaries that belong to the underwriting departments. And in second hand, as I said before, optimizing costs, basically we can predict and we can know in real time what our needs regarding these small and medium enterprises regarding insurance, so we can be in advance offering new products and customized products. So we contribute not only that the insurance company can sell more, that let's say we can eliminate the under insurance that normally companies they are suffering because they don't have a good or perfect knowledge of the risk. And last but not least, we can improve and risk model like loss ratio risk model in order to avoid losses in insurance companies. So how it works? With just the challenge at the beginning of the project of this pilot was that with just name and address of the company, we were able to get information from open data sources that can update and reach unverified information that companies has of their clients, not only current ones, also future ones. And we are getting it. We are getting more than 70 data points that are based on the more, let's say, traditional ones like employees number, financial, etc., but also the non-traditional ones like web and cyber, activities, location, opinion of the clients of these small and medium enterprises, etc. So we are focusing a huge market. The business innovation in that size in our pilot is that we are addressing to a huge market because we have developed this pilot very scalable. So we are, as a first step, we are focusing as a service obtainable market to a market of 1.2 billion euros just in Europe. Well, we have some competitors, but we are ahead of them because our aggregation computing, everything is not just based in just to get information from the open data sources. We have developed a proprietary technology that we are Lean or LeanScape, for example, another solution from Infinitech. So our competitive advantages is aggregation computing, proprietary artificial intelligence, and flexible architecture. That means that this is a very important one. That means that this flexible architecture is so flexible because not only we can adapt to any kind of sources of information, be structured or unstructured, also we are very capable to connect those information that we output from the platform with any kind of insurance. So we don't care about the IT legacy that these insurance companies has. And just to have an idea, all of the architecture that we have developed, when we don't have anything analyzing inside the, let's say, the machine, the cost is extremely low. Is only $8 per day. So from this basic cost, we can escalate to any kind of volume of information, not only to retrieve, also to send to the insurance companies. So the technology is already on place. We are just doing the last implementation. Has, as I said before, high scalability, using artificial intelligence, and has high performance. With all of that, we impact in the whole value chains of the insurance company. So with focus on small and medium enterprises, we can automate the submission of quoting and up to 90%. We can optimize the obtaining data from clients to underwrite up to 85%. We have improved loss ratio in 3%. That maybe 3% could be just a few, but I want to put in context. For example, for a medium-sized company based in any country in Europe with 50,000 small and medium enterprises in their portfolio, this 3% of improvement means that they are going to save 3 million euros per year. And finally, this for focus to upsell and cross-sell to know what are the next steps of the clients, what are the new needs from these clients regarding insurance, because they are going to open a new shop, so they are going to have a new property, they are opening a shop online, or they are changing the, let's say, director or managers in the board. So they are going to have changes in the configuration of the policies. So we are changing the paradigm of the insurance sector. Instead to push the channel, we are doing that the channel is pulling to the insurance companies. So we are already doing demos and testing with some of the most important players in the insurance industry in 2 continents. And well, these are more close the 4 use cases that I have been talking before. For example, first one, underwriting automation. In some, well, depending the policy and depending the country, in some cases, this underwriting can take up to 2 hours, the submission of the policies, because they have to not only get information from the client, they have to check that this information is real and is right. So we can reduce these 2 hours up to 10 minutes of submission, so they can save this 90% that we were commenting before. This is a demo that we have done with Mafra in USA. Second use case, data improvement, is regarding that one has been sold. For example, 3 years ago, nobody from the insurance company contact again yearly to update information that is contained in this policy. But all of you know that companies evolve, so this information normally is not updated. So you can think in yourself, how many times every year the companies with you have the insurance personally called you to know if the risk of your homes has changed. So it's the same, but in companies. So the second use case is to improve every year the information of these clients that are in the portfolios of the insurance companies, in order to, when the yearly renewal arrives, the information to renew the policy is updated. So in that case, in the demo that we have done, or we are doing with Hiscote in Spain, clients, they have updated 85% of the critical data that they have with clients. Third case is product recommendation. This is maybe much more easy to understand. It's just to predict and to advance the needs regarding insurance that the companies they are going to do. So as I said before, for example, one of the effects that we have detected during the pandemic is that there have been a lot of companies or small and medium enterprises that have to be turned into online. So the number of websites, the number of online shops, the number of commerce that has been added to Amazon, to other platforms like, for example, Globo or Just Eat or whatever, depending on the activity of the company, has been huge, because it was the unique channel to sell their products or services. So this has to be adjusted in the policy. And if the insurance company don't have, or they don't count with us in order to do it automatically, they cannot do it manually. So with that, we are identifying that 65% of the companies in one portfolio of one insurance company has at least one change that affects to the company, to the policy, and can generate more incomes through cross-selling or upselling. Last, fourth case is low reach improvement. I have been talking about that. That has been made with Zurich, with just open data, combining 4 risk indicators that we get directly from open data, and adding this information to the already model that the insurance company has based only until then in traditional information. We can update the level of risk, so we can do this model better in 3% at least. That means that when the renewal arrives or they are going to sell a new policy, the pricing is going to be much more accurate. So it's not only benefit for the insurance company, it's going to be benefit for a small and medium enterprise because they are going to be rated and they are going to be quoted by a very fair method. That's all. I'm going to show you just a brief video regarding the platform so you can see by your own how it works. Hi, welcome to the pilot team demo video. We get information from SMS clients of the insurance companies. So the main connectivity system is through API, but for demonstration purposes, and to the consortium and to the clients, we have built this kind of navigation through browser. So here, underwriting or people from insurance company can upload the name of these clients, SMS clients of the insurance, one by one, or just uploading a CSV with the name of all the companies that they want to analyze. So after that, and depending the needs, we can do it in batch or in real time. We will get all the information from all the companies that has been uploaded or interchanged through API. The main information that we are retrieving from these companies is 2. One is raw data, focus on this goal of data cleansing and to automate processes through fast quoting of the policies and the indicators that measure the risk of these small and medium enterprises. So in case that we can check the information coming from these companies to automate processes and data cleansing, we have to press this button, and through this we will get all the information regarding this company in several areas like general information about the company, business hours, government, management, property register, like which is how is the place where the company is doing business and the business, and also we can detect other keywords that help to the underwriter to rate better the risk. And also we can do it for some particular industry like contractors and so on. And also the underwriter can watch and inspect the risk, adding with the location. And sometimes if this enterprise has images in internet, we can also inspect the business inside, always respecting the GDPR regulation. And as a second part, this is basically raw data. And for the third goals that we have set up in this pilot 13, we also can build the data risk map in order to rate the risk of this company. We can know the cyber risk, the risk to follow or not the relation regarding GDPR, and how it varies and evolves in the timeline. Also regarding corporation, reputational risk level, management risk, social media level, and business continuity level is that the probability of this company to, let's say, survive to one a stressful situation like the pandemic of COVID, and also the team and the insurance needs like cybersecurity insurance, directors and officer insurance, and general liability insurance. So that's the demo of the pilot 13 regarding insurance for SMEs and how we can know better the levels of risk of these companies. Thank you.
So, hi. Thank you. This is a presentation for Pilot 13. So please, as you have been doing in the chat, your contribution answering the forms is very important for us to evaluate the projects, the pilots, and how useful can be for the industry. So I just insist that as much participation will be more than welcome. Thank you, Carmen.
Thank you, Carlos. Lucille, have you launched the questionnaire for this pilot? Can you confirm you are getting answers? We can give a couple of minutes to the audience in order to answer the questionnaires.
Yes, we have three responses.
Okay.
Thank you for those who answer the questionnaire.
Okay, let's go. In the meantime, do we have any question for Carlos? Someone is typing. Carlos, do you have a question? Is how do you make sure to reduce the data noise? And do you manage missing information?
Well, regarding, it's a very nice question. To reduce the data noise is, I think it's more or less the same when we talk about how accurate is the information that we are getting. So why or what are the reasons to know that the information that we are getting and we are sending to the insurance companies there is correct? So the things that the main reason is that we can check this information from several sources, do the low cost and so efficiency in our platform analytics is so low that we can retrieve information from several sources. So we can contrast the information that we have found. We can choose the information that is more, updated because it's more recent. And also we can evaluate if this information has been, let's say, published or put in this place by some owner, something that belongs to the company or has been a third party in order to do that. Obviously, we have internal algorithm models to check the noise, the level of noise, and how reliable is this field of information that we are going to shoot finally with the insurance company. Regarding how do we manage missing information? Normally, the level of information that we can retrieve from the, let's say, first analysis is almost from 60 to 75, maybe 80%. So we are able to get from first hand mainly all the information, but not in all fields, but in some of them we use synthetic data that has been retrieved, and this modeling get from same companies with maybe the same activity, the same geographical situation, etc. So let's say the answer for this second question is that we use in some fields synthetic information that we retrieve from the model from these companies that we are able to get information. You're welcome.
Many thanks, Carlos, for your explanation. I think if we don't have more answers, we can go for the last but not least presentation of our colleague, Grigoris Mygdakos from Agro Apps, and he's going to present the Infinitech Agro toolbox, big data, and climate risk analysis for the agriculture insurance sector. Please, Grigoris, the floor is yours.
Thank you, Carmen. Thank you, everyone. Of course, the last presentation is around agriculture insurance. And as you realize, and the colleagues will allow me to borrow some examples from their presentations, the scheme is not much different. Like it used to be, and we have seen it in some cases in UK and US, past myths saying that drivers or owners of red cars are more tendent to be involved into crashes, or that everyone that is running every weekend is less, let's say, risk secure against health issues. Technology is here, big data is here, and within the Fintech, us alongside with the rest of the partners, we are performing, we are developing, and we are validating services that can reduce the risk and the costs of the respective sectoral companies. We started and we're working on top of the pilot 14 on working and delivering easy access to services that build on top of big data and IoT information, alongside, of course, with our pilot leader and valuable co-partner, Genilard & Co. We started developing pilot 14 on top of specific, let's say, issues, pain points that we have identified together on the insurance and more especially on the agri-insurance sector. You will notice that they do not differ severely from the rest of the insurance sector, but nevertheless are still evident even during 2021 and as we are moving to 2022. I will very quickly highlight some that, of course, past myths or past data or historic records are not most of the times accurately recorded and can lead to misuse of or to misdesign of products. We have a high variability of extreme weather phenomena because of the climate change. So in simple terms, past climatology does not reflect accurately the future frequency and severity of events. Of course, insurance is a sector where until now, the damage handler or the insurance companies need to visit the crash of the auto or the damaged parcel and check a correct or false claim, make the assessment, and provide the report to their insured customer. This, of course, involves costs in terms of damaging assessment, on visiting, on managing false claims, etc. All those together shall be considered under the one main factor that is also again common in all insurance sectors, and this is the bias of the human actor when performing the damage assessment we're discussing with their potential customer. So at the end of the day, Pilot 14 aims to give two main, let's say, advantages on top of two main pillars: to address and give information to the agriculture insurance on the knowledge of future risks by providing the most possible accurate risk information and probability factors on a localized level, information that addresses and refers to specific parcel that is contracted under them, and of course, to achieve in higher efficiencies and decrease the high operational and administrative costs that we witness also in this insurance sector. But let's take it one by one. How we aim to do this? We developed the AgI toolbox. The AgI toolbox essentially has three main pillars. First of all, utilizes big data analytics. It utilizes heavily the Earth observation aspect, and of course, the weather intelligence on top of innovative IC technology. What we are providing as a turnkey solution is access to the agricultural insurance companies on top of refined and localized AI and ML algorithms with regards to crop growth models for the crops that they insure. We provide to them access to more or less 14 terabyte of data size weather information, climatic and forecasting for the European Peninsula, and of course, petabytes of data of remote sensing images to check either past records or, of course, to have access to continuous monitoring of EU data. What is the added value of this? All this automates the process from underwriting a contract to managing a contract and bring on board one of your customers until monitoring the crop growth status of your insured parcels, but also take all this information at any given point, receive timely alerts, have everything visualized under either the AgI toolbox platform or through a hassle-free integration of your current ERP through the provided API. But what it is exactly that we are adding and we're bringing on top? We mentioned earlier on knowledge of risk and that past climatic records are not always representative. You see here just an example of climatic analysis data that can be used in underwriting. You see how the service temperature anomalies for 1918 until 2020 compared to the relative values of 1981 to 2010 for the area of Cannes, France. You can see, and not a huge variation, but you can see distinctive variation of those temperatures. And mind me, a temperature difference of +1, -1 can be a very decisive factor in whether a crop will be more or less susceptible to an extreme weather phenomenon. So through the AgI toolbox, either as I mentioned, through the platform or through the API, the insurance sector has direct access to the more lengthy, accurate, and complete historic data to perform the initial step of underwriting. What we complement on top of this complete timeline of data is, of course, forecasting. Either seasonal forecasting in terms of, as you see on the left picture, where we have the January 2020 seasonal forecast of average temperature based on a multimodal seasonal forecasting, or as you can see on the right picture, where we have the average temperature anomaly compared to the reference period for the whole European peninsula. The agriculture insurance industry, having all this information, can see whether they need or have to adjust either the premiums, whether they can, let's say, bring more products into the market that they are currently serving, or even enter new markets, given that they now have a greater and more complete information on their hands to design the products and their commercial rollout. What is also available within the AgI toolbox? It's not only, of course, temperature or only precipitation, wind speed, relative humidity, etc., etc. It's a huge list of either climatic parameters or derivatives of climatic parameters, e.g., frost days, that you can calculate, that you can analyze either with regards to past records, but also to future records, on top of different forecasting horizon that ranges from several hours, what will take place in terms of wind speed within the next 6 hours, to 6 months, but also to 10 years with the addition of more longer, let's say, window forecasting. All those parameters can be taken into account in the underwriting, in the monitoring, but also in the new product designing processes of the agriculture insurance companies. And one such example you can see here that we are currently working with our partner Wenalyze, where we attempt to design and deploy into the market for one specific pilot partner a new parametric product that is about frost insurance for orchards. You see that on top of the AgI toolbox, the insurance company can have a continuous analysis of what's the frost days data for the past year, what seems to be the climatology the 30 years behind, and according to our forecasting, to associate and leverage the premium according to the different levels. This will allow them to have a continuous high quality of data, objective data, to capture and design and take their internal decision appropriately. They can specify the triggers on top of their specific, on the localities of the area or of the market that they are addressing, and of course, at any given point, to automate the payouts. And imagine payouts in agriculture insurance is the main point of, let's say, increasing customer satisfaction alongside with the customer service and the rest. But that is the one pillar of the AgI toolbox, the pillar that has to do with weather. What we are doing alongside with satellite data, and of course with the crop growth models that are infused with ML and AI algorithms. We are offering, by combining all those details, we can provide yield predictions for any area over the European peninsula, of course, following a localization and customization to the local cultivation practices, to the local varieties, and the rest of the distinct characteristics. And we can have long-term forecasting of future yields for specific crops or even for specific parcels. You here see a long-term forecasting for the expected rain and yield of a wheat crop in Greece. Similarly, when we have a parcel or a contract, more appropriately to be stated, within the AgI toolbox, we have the continuous download and acquisition of remote sensing images. Those remote sensing images being processed give, on those lines that you see, those are the NDVI values. NDVI, quickly stated, is an index that provides the how good or how healthy, let's say, the crop growth continues to be. You see here the variation between the NDVI graph and on different barley parcels. You can see noted also with an arrow a frost event that was detected with the AgI toolbox, and you also see the decline of the NDVI values for all parcels as a result of this frost event. So the agricultural insurance companies having access to such information, to the crop growth of each parcel, they can have a quick view what was the calamity that, let's say, affected their contracts, whether indeed an event took place over the areas where they have insured parcels, and whether at the end of the day they need to expect claims to be as incoming to their organization. That means claims incoming, and having an event indeed affecting the parcels means payouts for them. But also not only, let's say, short-term or medium-term monitoring, but also long-term seasonal variability. You see here the results of monitoring or expecting, comparing the NDVI, how a specific cotton parcel did evolve within the time under, let's say, the period of an active contract. The line marked with green is the actual values observed through the use of remote sensing data, and of course the crop growth algorithms. And of course you see with orange or yellow, depicting depending on your screen, it's the reference curve, how we expected this specific parcel we use, having cultivated, having or sowed a specific crop like cotton, will evolve within time. You see how close those two references be. So understand that the reference curve is the expected, the forecasted curve and yield from outside, and the green is the actual observed utilizing remote sensing data. And of course, we mentioned that also a very specific case and a very specific pain point for the agriculture insurance sector is the false or the right claims, and of course the objectivity of the in-field visits by the human damage handlers estimating the damage. You here have an example of a hail event taking place this year and of the automated damage assessment performed by the tool. We use the pictures prior to the hail, and of course the pictures that we associate following the hail, and we are performing the damage assessment. This is only a paradigm here. It can be the damage assessment and the reporting can be done in several ways, in several different ways, depending on the process that the insurance company is following. At the end of the day, what I need you to hold and consider is that all this process that is being done automatically, it means that you don't need, unless it's stated by the regulation, to send or dispatch a team to check whether there is a false claim, avoiding such costs. You can make automatic resolvements of the damage so that you have a very quick idea on the next 2 days whether and how will be the potential payout. And you can then, even if regulation states that a person needs from your company to visit the parcel and make also a local damage assessment, you can even have a record of what the satellites and what the AgI toolbox did calculate as damage, and of course, what did your personnel, how objective they were in their damage assessment or during the on-field visit. And as I said, those are only some of the examples that can be achieved and some of the calamities that we have seen and that are currently operational through the tool. All in all, the tool supports right now the automated damage assessment monitoring of arable crops and of course on top of 5 main calamities. Storms, including hail and windstorm, floods, frost events, fire events, and of course drought. And all data that we have seen can be produced for any arable crop currently developed and available operational into the system, but also for any area over Europe, but also beyond. Below the calamity name, you can see the type or the combination of satellite data that we are using. Of course, I have showcased to you earlier on the level of detail coming from the weather information, the second pillar, as we mentioned, about the AgI toolbox. Lastly, the comment that you see at the top bottom of the slide, and it is also very important, it is that all this analysis can be performed on a parcel level, so every single time for a parcel, but also in a larger area, especially for events like flood and drought. Those are much more, let's say, area-specific events where we can see even the flood extent, the flood duration for a larger area, and even extend further from exactly the parcels that you have insured under your company. Now you will allow me to quickly change the share screen from the presentation to the platform and give you a very quick run around the platform. Okay, for the sake of the demo, unfortunately, I cannot showcase to you right now parcels that are currently inserted by our pilot partners in the area, but I will attempt to do so within our demo account. Let's start by the climatology. Within the climatology, you can acquire data, as we said, about different climatic conditions for any region in the Europe. You may enter and request any type of source of data for any region or even Europe or any specify any country, but also a very long list of climatic, but also climatic and derivative from the climatic indices. We'll quickly run on one of our pre-run, consider that we're requesting the frost days for Greece, and then we'll jump also to Europe. You see that you directly have access to the climatic condition and frost days results coming from ERA 5 for the whole region of Greece. If, for example, you already had inserted inside to the system the number of parcels that you either have currently under contract or parcels that are intended to initiate, I will click display list so that you can see this possibility as well. We can even take and see where exactly lies our one contract or one parcel that we have right now in our own account. And imagine that the same way you can have a multiple of points of interest representing each one of your contracts around on Greece and check whether and how this area or this parcel on which pixel or which group of pixels does this account for and how the conditions or the data are for this. This applies, of course, also for past records, but similarly for the future forecasting and the future weather information. Same applies, as I said, to results acquiring either only for one country or for one region, or for whole continents, like here in case for Europe, where we can have the frost days again, how they evaluate, how they change, depending on the area. And you can see that there is great variance between the states, the countries, and of course, cities, etc. But this is with regard to the climatology aspects. Let's see what we can do and assist you in the continuous monitoring. And continuous monitoring means that having inserted all your parcels or having inserted all your contracts into the system, the platform welcomes you with the points of your contracts and, of course, with potential alerts. We see here a demo parcel of one of our colleagues in Agro Apps. Specified the system collects and provides you with alerts about extreme weather phenomena, damages that may be occur or may come or may happen to your parcel, either for extreme weather phenomena, but also for pests and diseases. So you can distinguish when receiving a claim whether a parcel, whether one of your contracts, one of your customers had already damage within his parcel from pest and disease, and was not, let's say, everything that happened because of the extreme weather phenomena. By monitoring, we enter, we see where the parcel is, we have access to NDVI indices and another longer set of vegetation indices, biophysical parameters and vegetation indices. We get also forecasting for the next days and alongside with the alerts of potential phenomena. And we can move back and forth in time, seeing the vegetation, how it goes, whether it's growth, whether you see the monitoring aspects as we mentioned earlier, and of course, perform quickly damage assessment and acquire the damage assessment from the system on the basis of historical weather events or that happened earlier on. But let's quickly visit one of the other parcels that we have already in so that you can see what exactly I'm referring to by the continuous monitoring. Here you see a cotton parcel. You see the NDVI picture lastly taken for the 25th of September. We can move back and see the different levels of NDVI, but we can even pick points that we see problematic or that we want to see per pixel in detail within the parcel. We see the whole timeline of the NDVI values for the specific pixel, and also associated with red potential extreme phenomena or alerts that may have impacted. That's with the damage assessment and the monitoring, but how do you insert and why you shall insert one crop or one contract into the system? We also allow you to populate it. Let's go to the policies aspect and see how we can do. Of course, here it is grouped with regions, and let's go inside to check. Let's keep that this is a policy, and we want to add a new field, a new contract that we have inserted. Of course, name could be any alpharithmetic type. Let's say that the new contract that we have inserted in our policy is wheat. The expected yield, according to our forecasting, is around 300 200 kilos per hectare. The sowing date that was performed for wheat is 12th of November. So we mentioned that please system start monitoring the parcel from the sowing date of the farmer until the expected harvesting time, that is 10th of July for wheat in Greece, 10 to 20. Let's put 10. We might insert the insured value, and this is of course for you to fully utilize smart contracts within the system. Let's say that the maximum insured value is 15,000 for this specific. And then what we have to do is to direct the system on which exactly perils and calamities this parcel is being insured for in order for the system to keep and retain those records for you. Let's say that the parcel is for flood, fire, drought, hailstorm, we can pick any. And then in order to, let's say, to initiate the smart contracts of the platform, we need to specify the low thresholds and accordingly the payout amount. So if the system checks that there was a flood event that caused the 15% of damage, then here you have to insert 15%. And according to your policy, what's the payout that you need, that you are expected to give out to this farmer on the basis of 15%. Let's say that it's 20% of the insured value. Same applies for all parameters. Then we have only to design and say, what is the parcel? Let's pick one here in the prefecture of Larissa. It's quite straightforward which parcel it is. Let's say that it is this one. I'm just signing and telling to the system that all those information, this contract refers to this parcel here. I am done, and I press save. Okay, let's go back. So for quick reasons, save. And now, once the system saves this parcel, it is directly available for us and starts monitoring. It will start calculate all those indices that you have seen. It will go to the past from the sowing date to calculate the indices, acquire the images, and start also collecting weather information from for this specific parcel, for this specific area. Now you will allow me to go back to our presentation. All in all, what it is there and what we consider that is value provided by the AgI toolbox to any insurance company. There is a huge amount and huge capabilities of climatic big data and analytics on the fly at one click for you, for any insurance company to do available for any area within the European Peninsula and beyond. So you can at any given point make the best mix or the best analytics for you and underwrite accordingly or prepare your personnel or your operations accordingly. We support the objective remote damage assessment, even in the cases where regulation, we have countries where regulation does not allow fully, let's say, damage assessment without the use of in-field visits. We support insurance companies to have a first reporting so that they assist the damage handling teams on the field to make the most accurate, the most objective damage assessment. We provide 10 key AI and ML algorithms for yield analytics. You have seen the results of what you need to expect as productivity, and according to the productivity, you can, let's say, calculate and assign the right premium. To be prepared of the crop dynamics, yes, we have the climate change, we have different variations in temperature. Will there be something? Will the crops yield increase because of the changes of the average temperature, or will they reduce depending on the, let's say, lower temperature or higher frost events? Be prepared and know the crop dynamics and, of course, how the contracts and the customers will address you with their claims. Of course, all this, the added information will allow you to design more accurately your contracts, have a greater variety of premiums, and of course, diversify from competition. The system is also blockchain and ready, so you can build on top of the use of the smart contracts capability that has been already infused in the platform. We can, let's say, hassle-free integrate any of the blockchain infrastructures that you want, and have even, let's say, non-totally transparent ledgers of claims, of damage assessments, and everything else. This will increase further and automate fully your partial or fully payment to insure customers. This, of course, will improve the customer satisfaction, will help you to be different from your competition, and of course, all in all, to reduce your operation administrative costs while minimize incoming false claims and costs that are associated to it. What we can promise that through the AgI toolbox, depending on the efficiency that you are working now, you will achieve lower costs, increase efficiency, and higher customer satisfaction and retention rates. And with all this, I would like to thank you for attending the presentation. I'm at your availability for any questions. And of course, feel free to email me and the team to discuss on how we can work and how we can include your organization on our series of pilots under Infinitech, and how we can customize the tool for your requirements.
Thank you very much, Grigory, for your great presentation. Here we have the last questioner. Please provide your feedback to us. As we have said before, it's very valuable for us. Then I don't know if we have more questions right now. I think Lucille is saying something in the chat.
But even, Carmen, if somebody does not or wishes to send me later on questions, I will be more than happy to respond to them.
Perfect, perfect. Then I think if you wish, I would like to thank you all of you for attending this webinar. I hope you have time for reflect about our experience here in the Infinitech project. And again, thank you very much for your participation. And we will try to get more feedback from you in offline mode. And I don't know if my colleagues want to say goodbye to all of you. Also, I would like to wish you Merry Christmas for all of you.
To thank them for their time and patience on attending all 4 presentations, I would say, Carmen.
Yes, perfect. Yes, I agree. Okay, then.
Goodbye, everyone.
Goodbye and have a good week.
Bye. Thank you very
Thank
much.
you very much. Bye-bye.
Bye-bye.
Okay, bye-bye. Thank you.